and do that. Actually, I have forgotten to post the videos from class previously, so I need to do that too in the next couple of days. Let me go ahead and show you the code. It is uploaded to D12. So this is class project 3 version 2. This seems like a more digestible set of topics. I think the version I showed you in the videos was a little too big to be covered in one class. So this is probably a little better. Let me share the Eclipse window here. Okay. The packages are pretty much the same as it was in the videos, although I didn't really post that code on D12. This is the code that you will see on D12. You can see the packages here. I know it is very tiny. There is a package called controller, package called model, and a package called view. And they don't contain any GUI related code. They are all independent of JavaFX or Java Swing or any such graphical user interface. Then there is a main package from where you start the drawing program. And there are two other packages. One is called FX GUI. The other one is called Swing GUI. These are packages that contain JavaFX code and Swing code respectively. You don't need to see the demo here. What you can do are create polygons, lines, labels. Then you can also group, actually you can select shapes. You can select multiple shapes. You can group them, you can ungroup them. You know, you might have used group and ungroup through Microsoft Word. You can have a collection of shapes on Microsoft Word, and then you can group them into one unit and move them around or delete or whatever. And you can ungroup also. So that is grouping and ungrouping. And you can also delete and move those shapes. So that is the functionality. So let's take a look at how the program is organized here. As I said, this is the drawing program. This is where it starts. So the drawing program, I have written this in FX. There could have been a version that has, there could be another class using Swing. I didn't create it. I mean, it shouldn't be very hard to do that as well. So you could have another class that actually starts the whole thing in Swing. I did do that. And this is a pure JavaFX program because you need to have ultimately the technology in some place. And there are two buttons here, FX window button and Swing window button. And if you click on the FX window button, it creates a window through which you can edit, but it all uses FX technology. If you click on the Swing window button, it creates another window, but that uses the Swing technology. And you can again edit the same drawing. So there are these two buttons. Okay, how does it, how do these two things coexist? How do these windows, you can have multiple windows of Swing, multiple windows of FX, and they coexist. How do they do that? How do you do it? Well, we have FX window button, and you can click that as many times as you wish. You will keep on getting more and more FX windows. Same thing with swing. You can keep on clicking and you can get many windows. So what happens is when you click on FX button, it creates a graphical user interface, a window, and it also creates a view and a controller. So there is a view and a controller. These two contain no FX code, no swing code. And the controller knows about the view and the view would know about the controller, etc. And the graphical user interface knows about the controller and the view. The same thing is true here. A view controller pair is created if you click on the swing button, and you also create a graphical user interface which knows about the view as well as the controller. So all the code to accept button clicks, mouse clicks, key typings, etc., are either in FX GUI or swing GUI. Of course, this main program has to have GUI code as well, because that is where you start the whole program. But otherwise, almost all the code is either in one of these two packages. Then, of course, we have the controller package, which contains commands. We talked about commands last week. A command can be executed, undone, or redone. And there are commands for all the shape creations, operations to manipulate the drawing, like deleting, grouping, ungrouping, and moving. So you have commands for creating labels, lines, polygons, opening a drawing, saving a drawing. So these are the shape creation, shape retrieval, shape save, shape manipulation. So those are the command classes. Then there is an undo manager here. The undo manager maintains a history stack and a redo stack, and it has methods to undo and redo. When you have to undo, you pop the command that is at the top of the stack and undo that command, and then push it onto the redo stack. And to redo, you redo the stuff at the top of the redo stack and push it onto the history stack after popping it. So that is undo and redo. Then the model contains the model class. The model package contains the model class. It is basically a collection, as you know. You can add shape. You can add multiple shapes. Although I don't, you can add multiple shapes, and you can remove multiple shapes, or you can remove one shape. Those are all very simple pieces of code. I'm using an object adapter here, a linked list as an adaptee. Then there is an iterator to the shapes. And this model is, of course, is an observable. There can be multiple views. Whenever you create a new FX window or swing window, there is a new view created. All these views, if you had a dozen swing and FX windows, there will be a dozen views. All those views are clients of this model. Okay. And here is how you would save the drawing and retrieve the drawing. So you are using serialization to save and retrieve the drawing. One thing you would notice here, if you haven't taken ICS 440, which I doubt many of you wouldn't have taken, but if you have taken maybe 462, you might have seen this keyword synchronized. Does anyone know what synchronized mean?
Syncing the threads, so it's only one thread can access it.
Right, exactly, very good. What it means is that at any one point, only one thread can access this. All right, so actually that reminds me, I need to put in back. Yeah, only one thread can access this at any given point in time. Right, so only one action happens. Then there is an undo manager here that also has this synchronized on every one of these. Okay, then what else? Right. So the model is an observable, and all the views observe it. Then we have the other package, view, and there is a view class here. It is a listener for the model, so it implements property change listener. You should also note another thing here. Unlike the code that you saw last week, there is absolutely no Java FX or swing code here. There is nothing. So the graphical user interface is represented by a Java interface called GUI view. So GUI view is a Java interface, and it listens to the view class. So here is an interface called GUI view, and it has methods like set cursor to default, set cursor to drawing. So this is the arrow cursor, this is the crosshair cursor. A view is capable of, or rather a GUI is capable of giving you a renderer, and it can show a context menu, whether you want to, I mean, if you right click, you get a context menu, and you can dismiss the context menu. So those are the methods of the graphical user interface. So this is implemented in Swing as well as FX. So if you look at, it gets complicated as you start looking at the graphical user interface code. For example, here, swing drawing panel. This is the drawing panel where you actually draw stuff. And this is the swing drawing panel. It extends a swing class called JPanel, and it implements the GUI view interface, which we just looked at. And it has obviously those methods to change the cursor to default, to drawing, etc. So you have all swing code here, and it has methods to get a renderer. So there are two types of renderers in this particular implementation. One is a normal renderer. The other one is slightly different in the sense it will highlight one location in each shape. So there is a highlighting renderer as well as a normal renderer. So you can either get a highlighting renderer which happens if you set this flag to true, otherwise you'll get a normal renderer. And there is a context menu we talked about. So the context menu is created in Swing using all these classes like JPopUp menu items, and all that. I mean, the code is pretty complex. You create all these menu items. So these are the operations: group, ungroup, delete, and move. You put all those into the pop-up menu and show that when you need to, right? So for example, pop-up menu dot show at this location, right? And you can hide the pop-up menu like that. So that is done at the will of the view class. So this drawing panel gets commands from the view class to show the pop-up menu or hide the pop-up menu, but it also receives clicks on these pop-up menu items. So if you have to delete, you would create the pop-up menu and click on the delete item. So you would right click, you'll get the pop-up menu, and you click on the delete item, delete menu, and you will be calling the controller's on delete request. If you were to group a bunch of items, you will call the controller's on group items. So you have all these methods that are called from this Swing drawing panel. Ditto for the FX drawing panel. You will see similar code here, but everything done using Java FX in this class. So it is not JPopUp menu, it is context menu. And you have menu items for group, ungroup, delete, and move. And you have similar code here. When you click on the delete menu item, we have, you might remember this from the library implementation, these lambda expressions, right? And we are calling the on delete request. So you end up in the same controller code: on delete request, on group items, on ungroup items, etc., etc. So you end up in the same place. Okay. Then we have code to handle key pressings, that is backspace and escape. Those are the only keys handled in this version. Escape is to abandon the current command, and also to deselect any shapes that you have already selected. I don't know whether it is deselect or unselect, whatever. Backspace is to when you create a label, backspace will delete the last character. So this senses the pressing of the backspace key, and then you call the controllers on backspace. So the controller doesn't know how the user actually ended up requesting for backspace, or here, how does the user actually abandon a request? We know that they have to press escape, but the controller doesn't really care. It knows that the current command has to be abandoned. So it has this method called on abandon request. And in the Java FX code, I have a separate class to handle key typings. Okay, so when a key is typed, I will get the character and call the controllers on character typed. Okay. What I want to now talk about is the bridge pattern. We have two types of GUIs here. One is the Swing GUI, the other one is the FX GUI. So let me show you how something gets drawn, or how the drawing gets displayed. So for that, let's go to the model class. Let's look at this method. Suppose you added a new shape, okay? Perhaps a label or whatever. We add that shape, the shape is here. We add it to the list of shapes, that is shape list here. And then we call update view. I think we looked at this before too, but update view is called, and we fire property change, which means all the listeners will be notified. So we have the views all stored in this property change support. All the views are observers. So the view gets notified. So where does it do that? I mean, the view gets notified here in the property change method, and a shape has been added. The view gets notified. In fact, every view gets notified, and each view will call a method called update. So let's look for that over here. Here is update. And what does that do? It tells every listener. Here you will only have one listener, but I just did it in a very general way. There is only one graphical user interface attached to each view. If you had 10 different views created, 10 different graphical user interfaces created, each will be a client of one view. So every view will have exactly one graphical user interface. So you don't really need an elaborate mechanism like this, but I just wrote it that way as a property change listener. So I just look at each listener and tell them that they should be now modifying themselves. So I'm calling for each graphical user interface that is connected to me. And let me repeat this, there is only one. I will call I will tell them that the property change method has to be invoked. So the property change method for the swing drawing panel swing is a bit of a pain actually compared to FX, but because it works in a somewhat strange way. You call the property change method and it invokes a repaint. The repaint at some point in time will call this paint component. So it is not a direct call to repaint, to paint component. You're scheduling a repaint. FX works slightly differently. In any case, in swing, we have to call super.paint component. So we are redrawing the swing window. This is the first thing that you do in a swing GUI paint component method. And we get the graphics object. We get the graphics object as the in the renderer. So here we have one renderer for all swing windows because everybody is sharing this renderer. So swing renderer.instance, we set the graphics so that that renderer will go and draw on this particular GUI. Okay, and we set the color to blue and so on. And we also set it on the highlighting renderer. So both renderers are, I mean, only one renderer will be used, but whichever renderer the view uses will end up drawing to this window. There is only one renderer for swing and there is one renderer for FX. And look at what is happening here. We are calling the draw method of view. So the view calls the property change method, which schedules a repaint, and this calls the draw method of the view. So you're going back to the view, and we are calling the draw method here. And what we do is we get all the shapes from the model, and for each shape that I have in the model, I call the render method of that shape. Maybe this should be changed to shape or something, this variable name. Anyway, I get the renderer object from the graphical user interface. So this view, or maybe this should be called GUI view or GUI or whatever, I ask it to give me a renderer. So it will either give me a highlighting renderer or a normal renderer, and I tell the shape to render itself using this particular renderer. So you need to go to the shape class, let's say line. We will be going to this render method using the renderer supplied by the graphical user interface and given to this by the view class. It calls the superclasses render method and then draws a line from one endpoint to the other endpoint using the renderer's draw method. So the renderer, whether it is FX or swing, will implement this interface called renderer. And there is a draw method to draw a line, a draw method to draw a piece of text, a draw method to draw an arc so that you can actually draw circles if you want, a draw method that basically does nothing. It's a catch-all kind of thing. You should never be coming to this method. There is a set color method, and there is a draw method to draw a single pixel, and this will be used by the highlighting renderer to highlight a single pixel. And if you call this set selected, you can either draw in normal color or default color, which is blue, or in the selected color, which is red. So there is a bunch of basic methods a renderer will do. And the line class uses this particular method to draw a line. Oh, sorry, not this one. This one. To draw from one XY coordinates to the other XY coordinates, set of XY coordinates. So we have that called here. And super.render will actually be calling the superclasses render method, which is the shape class. All right. And if the shape is currently selected, this will be true. Otherwise, it will not be selected. So whenever you select a shape, you will be calling a method here that will change selected to true. When you unselect it, this will be false. So there is a set selected method, okay, which can be called by the controller whenever a shape is selected. And there is something called a highlight point. For every shape, there is one point in the shape that is highlighted if you want it to be highlighted. So there is a highlight button, which I think I went through in the videos. If there is a highlighting button, we will highlight that particular vertex. Otherwise, we will not highlight it. I mean, if there might be a shape for which we don't have a highlight point yet specified, in which case I don't want to crash. But the renderer will decide whether to highlight or not. If it is a highlighting renderer, it will highlight it, otherwise it will not highlight it. So that is what a renderer will do. So you can see that the shape class like line has no code that says whether it is a swing window or a FX window. It simply says, okay, I got a renderer, I'm going to render using it. That's all it does. So the view class knows the GUI that is attached to it, but it still doesn't know whether it is a swing GUI or an FX GUI. It simply asks that to give it a renderer, right? And the GUI knows, of course, what kind of technology it is using. It creates the right renderer and gives it. That is the bridge pattern here. There is another class that I will briefly go through. It's not very difficult, actually, which we didn't look at. You can select shapes. You can press the control key and click on the mouse on a shape. And if it is close to a shape, the shape will be selected. And all the selected shapes are stored in a singleton object called selected storage. So this has a list of all the shapes that have been selected. Right? So you can add a shape to the collection of selected shapes, or you can remove shapes. Okay, you can get the size, etc. So when you are when you get the control mouse click input from the GUI, let's go here and look for the code. When you get control, yeah, this one. When you press the control key and click the mouse at that while the control key is pressed, this method gets called by the appropriate GUI, and it tells you which point it is. By the way, this canvas point is a custom class that is independent of the GUI. If you use something like point 2D, it is JavaFX stuff. So I don't want any such thing in my controller or view. So I'm using my own custom class called canvas point. Anyway, this point is the point at which the mouse was clicked with the control key pressed. If there is no other command going on, we ask the model, is this point close to a shape? If it is close to a shape, that shape will be returned by the model. And if there is such a shape, if it is already selected, we unselect it. We remove that shape from the selected storage object. If the shape is not already selected, we select it. So if you press control mouse click, either it will be selected or unselected. If it is already selected, it will be unselected. If it is unselected, it will be selected. So we will either add the shape to selected storage or remove the shape from the selected storage. And we will update the view. So when the shape is selected, it will be marked as selected. So it will show up in red. That is what we are doing to show that a shape has been selected. And if you go back to the controller, oh yeah, here it is, we are in the controller. If you press the escape key, it's probably up here. Yeah. If you press the escape key, and if a command is not going on, you can unselect all the selected shapes. So it clears the selected storage. That is how you get rid of all selected stuff. You cannot do undo or redo while a command is going on or while there is something selected, because it is dangerous to do undo and redo at those times. So we don't permit any undo or redo if there is a command going on, or if the or if some shapes or some shape has been selected. Now, let me pause here and see if there are any questions, because there is something else I want to show you regarding this program. Okay, it is a complex program, and I reduced the complexity from the version because I didn't want to do any drag, drop, or copy paste, because that simply made it extremely difficult to understand. So there is nothing of that kind over here. Now, what I want to now show you is, what do you need to modify if you want to add a new shape? There will be a question of that kind in the third exam. So you need to understand this. So suppose you want to add a new shape. What all things do you need to modify? Okay. If you think about it logically, suppose you want to add a new shape, then obviously we need a new button for that, because the way that we have been doing it is for every shape, there is a corresponding button, label button, line button, polygon button, and so on. So if you want to add, say, a circle, we need a circle button. So the line button looks like this. Line button extends GUI button, and this is it, actually. It's a very small piece of code. So what one can do is copy this and modify it. If it is circle button, you'll change this to circle button, and you will need a new command in controller to handle circle creation. So proceeding logically, the next thing to do is to actually change the controller. So the controller has one method for each shape, like on label command. If no command is going on, we will honor that request. Or line command. If no command is going on, we will create a line command. So we need to create a circle command in this case. And every command has the same set of parameters. It is the controller and the view. Controller and view, or line command, or polygon command, controller and view. That is the next step, which means we need a command class like polygon command or line command. We need a circle command. So we need a class like this, public class line command extends command. So we will have something called circle command extends command, which means we need to have something like this in our new shape, new command. The shape that is being created, in this case it is line, but if you're creating a circle, you will have a circle shape. And we will have execute, abandon, etc. And we should decide what requests should be handled. Do you want to listen to clicks specifying points? Do you worry about cursor move? That all depends upon how you want to draw things, right? So there is a set of methods in controller that handles all these different things, right? When you type a character, control comes here, backspace, control comes here. Then control mouse click, control comes here, point input, control comes here. So which of these things, all of these things are sent to the current command, but which of those do you really want to handle? That depends upon the shape. So you have to decide on that. Actually, that is the wrong place, line command. So you need to decide which inputs should be handled. Do you want to handle clicks on the window? Probably yes, for most shapes. In any case, that is something that is dependent on the shape, but you also need to create the shape class. So that is the other thing. So you need to go to model.shapes and create a class like this. So here, if it is a circle, you need to decide how you want to represent the circle. Maybe you can represent a circle using the center point and the radius. And you need to have this constructor, something like this. Maybe this would become the center point of the real thing, right? And you need a render method, which would be somewhat like this, but instead of drawing a line, you will be drawing an arc. Instead of setting the second point, you may be setting the radius, etc. And another method that we didn't talk about is the move method. This moves a shape by delta x, delta y. So I'm moving, to move a line, I move both endpoints. Undo and redo of any new shape will automatically be taken care of, provided you create the corresponding command class. You don't have to do anything extra for that. Okay, so that is a summary of this second version of the drawing program. So this would be essentially the code that you need to modify when you do your third exam. So you need to be familiar with this. And tonight's class exercise is entirely on the code in this version. There are about 35 or so questions. I mean, there is, that only covers a part of this. There is, I mean, I was worried that it may take a long time for you to complete even those 35 questions or whatever number of questions there are. I could have created even more questions, but I decided not to because it might be too much. So you should go through how a single shape gets created. Maybe take line or polygon and trace from the FX window all the way through the completion of the shape. That will be very useful. Okay. Any questions before we stop this? All right. And I may not get a chance to say this again next week. There is an opportunity to improve your score for the first question of the first exam, of the second exam. So there will be a use case for the library, and it is entirely optional. But we will stop the class exercise at 8 o'clock and start the exam after a few minutes after 8. Okay. All right.